This is 2016 paper 1, question 4b. It's a question on logs. And in this question, we have to give our answer in terms of P and Q, where P and Q are given to us here. P is the log to the base A of 2, and Q is the log to the base A of 3. So let's get started on part I. The log to the base A of 8 over 3. Well, we can rewrite that. There's a rule that helps us down here. If you go to page 36 of your tables, you will see that there's a rule. The log to the base A of x over y is the log of x minus the log of y. So we can write that in our case as the log to the base A of 8 minus the log to the base A of 3. So that's the first step. Now we can see at this stage that we already have Q, because log to the base A of 3 is Q. So we can replace that. Now log to the base A of 8. We need to work with that a little bit, because we can only use log to the base A of 2 or 3 if we want to bring P and Q into it. So we can rewrite that as the log to the base A of 8 is actually 2 cubed. And now we have our 2, but we've got a 3 in the power that's in the way at the moment. And there's another rule we can use to get rid of that. So if you come down here, the log of 2 cubed, we can use this rule. The log of x to the power of q. You can see there that the q comes down in front of the log, so we can use that. So that 3 is going to come down in front. So it's 3 times the log to the base A of 2 minus q. And now we have what we want, because the log to the base A of 2 is actually p. So the answer is 3p minus q. And that's part I done. Now part 2 starts off in a similar way, the log to the base A of 9a squared over 16. So what we can do here is we can separate those again using the same rule. The log to the base A of 9a squared minus the log to the base A of 16. And again, we've got to force 2 and 3 in there somehow, because that's how we get P and Q into the answer. So we can work with this a little bit. It's the log to the base A of 9 can be written as 3 squared. So it's 3 squared A squared, and put a bracket around that, minus log to the base A of 16 is 2 to the power of 4. And now we can tidy up further. The log to the base A of 3a in a bracket to b squared minus the log to the base A of 2 to the power of 4. And now we can use that rule again that we used previously, where the power comes down in front. So that 2 comes down in front of the log. So if we write 2 log to the base A of 3a. And the same here, the 4 comes down in front, so it's 4 log to the base A of 2. And we can tidy up further here. 2 log to the base A, 3a. If you look down here, there's a rule that can help us. If you've got the log of xy, that's the log of x plus the log of y. So it's the same here with 3a. That's actually the log of 3 plus the log of a. And they're both to the base A again. And don't forget the 2's outside still. Minus 4 times the log to the base A of 2. Now we're getting very close to what we want, which is having everything in terms of just P and Q. Because again, if we go back to the top, log of 2 is P, log of 3 is Q. So log of 2 is P, log of 3 is Q. So now we just need to fix the log A to the base A. So up here we can fix that. So log to the base A of A. Let's just call the answer y, whatever it is for the moment. And now we can use this rule down here. So it's all about knowing how to use your rules of logs. You can see here a rule that allows you to go from logs to powers, or vice versa, from powers to logs. So this time we're going to go from logs back to powers. So we're going back this way. And we're going to get a to the power of x equals y. So in our case, that is a to the power of y equals a. And just by observation now we can see that y must be 1. So our original log to the base a of a, which was y, must be 1. So now we have this as well, and we have our final answer. So our final answer is 2 times the q, log to the base a of 3 is q, plus log to the base a of a is 1, minus 4 times log to the base a of 2, which is, of course, p. And that's the final answer. Everything is in terms of p and q only. So there's question 4b, 2016 done.